Hello, I just wanted to share a little prototype program I've been working on over the past couple of weeks just because I think it's cool. When learning about neural networks, I found it hard to visualize, like the output space of the neural networks, how error changes over time, things like that. So I just wanted to attempt to make a neural network visualization program on my own, and maybe other people will find it cool as well. So for a neural network, you need a problem to solve, some set of inputs, and an output value. I chose to represent kind of the simplest neural network possible that you can have here, so two input values and one output value. In this case, we are going to be classifying the color of flowers. So the first input will be the width of the flower petal, and the second input will be the length of the flower petal. And with that information, the neural network will predict whether it is a red or a blue flower. But essentially you'll have this neural network architecture tab here. This defines like how many inputs you have, which in this case will always be 2, and the output will always be 1. But mainly this is to change the activation functions and the hidden number of hidden neurons in the network. So there will be 2 input neurons and then 10 output into the hidden layer here. And then obviously the output of the previous layer will be the input of the next layer. So essentially this network has 2 input neurons and then a hidden layer with 10 neurons, then another hidden layer with 5 neurons, and then finally an output layer with 1 neuron, and then all using the hyperbolic tangent activation function. So how will you get the inputs to train this network, you might ask? That's what this 2D graph tab is here for. So on the y-axis is the length of the flower petal, and the width of the flower petal is on the x-axis, just 0 through 10, kind of an arbitrary value. Um, but essentially, if you left click, you can place what are essentially data points or like truth values for this network to train based off of. So if you have this width and this length of the flower petal, it'll be a red flower. And if you right click, you can place blue flowers. And essentially, this is kind of all the network needs so far to run. It now has an input set, and it can now be trained. It knows what the actual network architecture is. There's just a few more parameters that need to be changed or modified depending on what you want to test. These first 2 buttons don't currently work. Still working on that. The epochs, how many epochs the network will run for. The learning rate, the error threshold. This is basically just when the network stops training. So if it gets to a low enough error value, which is this right here, then it'll stop training because you don't need to keep going if you're kind of satisfied with the output. Um, you're just wasting compute at that point. Start training button, obviously it'll start the training. Then a pause and stop training button, which I haven't implemented yet, and then clearing this, pressing clear graph will clear this 2D graph here, and then a 2D heat map, which I'll show you here in a second. So if we just press start training with this default parameters, you can see the progress bar 100%, so it's finished training. So what will the network predict after it's been trained based on this input? Well, you can kind of see that here with this 3D graph. Um, so on the, you can kind of see the X and Y axes here. This kind of allows you to visualize the prediction of the network more easily. So 0 through 10, obviously, the length of the flower petal on the y-axis, the width of the flower petal on the x-axis, and then essentially what I did was took a bunch of random points on this grid and then passed it into the network to see what it would predict. And that is what the output is, this y, or sorry, z-axis here. 0 being a red flower and 1 being a blue flower. Um, so if you kind of tilt it upwards, you can kind of see how it's separated here. So it kind of did a bit of a backwards L here to separate those red flowers and differentiate, and then the blue flowers over here um, all lie within this area, and that's kind of how it predicts. So um, if you passed in like a random point, say like 6, 8, it would predict that it's a blue flower. And if you train the network again, you can see how the output space changes here. But this is kind of hard to see if you look like this and then keep going back and forth to compare it. That's what this 2D heat map is for. So this will actually show you how the network would predict given a width and a length of the flower petals. And if you keep training, you can see how that boundary would change. Um, See, this one's kind of interesting. It technically um, trained properly, and there's no error based on your input data, um, but it kind of made a bit of a channel here for these red flowers. So it's kind of interesting, and then this obviously you can view this same information only with a 3D view, um, as you can see here. And then this error graph just shows the error of the network over time. So it kind of wasn't really doing anything for the first, I don't know, 17 epochs, and then suddenly it found a solution very quickly, and the error dropped to near zero. Um, but that's not very interesting, right? Because this network isn't very complex. So if we clear this and I middle click, it will randomly place a bunch of points. And then you can train based off of that. Um, but will our small little network here be able to handle such a complex um, data set? Probably not, but we'll train it and see. Um, so if we look at the 3D output, it doesn't look like it did very well. It really struggled here. Um, it kind of got some of the flowers in the red zone over here, but then the rest it basically um, decided were blue, and this is probably just a limit of our neural network architecture here, kind of like the layout. It doesn't have enough neurons in our hidden layers to actually predict um, a accurate model of this data set because there's just so many points. And they're pretty close together. So if we change this to something like 70 in our hidden, and then change this to like 10, and then bump down our learning rate a little bit. So let's go 0.01, and then we trained our network again, what would we get? It looks a little odd. Doesn't seem to be doing too well. And this one actually does appear to be predicting properly now on a second try. If you can see the 3D graph, it gets kind of complex. Um, so depending on your input X and Y values of the width of the flower petal and length of the flower petal, it can get kind of strange looking. Um, yeah, you can kind of see the comparison here between the 2D graph and the 3D output. Um, so this is actually kind of a pretty good prediction. Um, but if you added more points, say you put like a red point here and then trained it again, what would it do? It's still kind of struggling, right? So let's bump this up to, let's say 20 for this hidden layer here. We'll actually clear our graph and then put some new points here. Let's get something, see if we can get something a little more interesting, and see how this reacts. So if we train it here again, toggle our 2D map, it looks like it did a pretty good job at predicting. This white is basically in between, between the red and the blue. You can kind of see it here better on this graph. So it's kind of in the middle. It's between 0 and 1. It's kind of around that zero point 0.5 range. It doesn't really know what to predict. It's just kind of unsure on what that prediction would be, um, and whether it'd be a red or a blue flower, just because it's like so close to some of these boundaries. Um, but yeah, you can kind of see the error graph over time as well. Um, Essentially, had a pretty high error at the start, obviously. We kind of decreased steadily, and then we had a jump here. Decrease steadily again, jump, decrease steadily, and then we kind of had just kind of a mess down here until it eventually stabilized around epoch 550 um, and gave us a decent representation of our network where there's just kind of a big pool of red here, a couple red dots here. The only one that didn't really get caught was a red dot right here just because it was kind of so close to uh, this blue flower here. And you'd essentially just need a more complex network to be able to, for the neural network to predict a differentiation here. If we run it again, let's see what we get. Nope, it's still not predicting this red dot over here. but it's you can see how it varies widely on like your generalization. So if you were just given a random input point that you've never seen before, like 4, 2, right? It would predict blue, even though it's kind of like in between these two red flowers. The way your neural network trained, it would actually predict blue. Um, and the error graph, again, kind of a roller coaster with this odd architecture here, but it kind of gives you an idea of what's going on. And then this prediction tab I haven't really implemented yet, but I hope you found this entertaining. Um, Hopefully I'll keep working on this, kind of polish up the code. This has kind of like been a prototype project, so the code is very messy. I've just kind of done it as fast as possible just to see if it could be done. And I'm kind of happy with the results so far, so maybe I'll clean it up. Maybe I'll change what the problem is to solve. Maybe I won't do red and blue flowers. Maybe I'll do like um, handwritten digit recognition or something like that, and have some kind of visualization in a more refined program later down the line. But hope you guys all enjoyed, and hopefully I will do something like this again in the future. Peace.